Let me also start the transcript. All right, welcome back to Intro to Speech Understanding. And now let me go ahead and start Anaconda. So as you may remember, let me bring up GitHub here. Here we go. We've covered the first 2/3 of the course. As you may remember, in the first 1/3 of the course, well, here, let me find it. Documents, GitHub, Intro Speech Understanding, 2025 spring. In the first 1/3 of the course, lectures 1 through 5, we covered an introduction to Python and an introduction to NumPy so that you could understand how to use the basic programming language features and also how to use the basics of matrix manipulation and vector manipulation. In lectures 6 through 10, we covered really the basics of speech signals. So I taught you about how speech is produced by the vocal folds closing together once every 10 milliseconds or so, and that excites the formant frequencies of the vocal tract. We can model that as the sum of cosines and sines added together with an appropriate phase and amplitude. We can find out what those amplitudes and phases are by performing a Fourier transform. And then we can reconstruct the speech signal by adding together those cosines with the appropriate phases and amplitudes. And so by looking at the spectrogram, it's possible to recognize which speech sound was being produced. And then by adding together the cosines with appropriate amplitude and phase, it's possible to reconstruct those same cosines. And so now you have the basics of speech recognition and speech synthesis. You have the basic idea of what the software does behind the scenes when your computer recognizes what you said or when it produces what you want to hear. In the last 4 lectures of this course, we're going to switch gears a little bit, and we're going to talk about mechanisms for using, really we'll be talking about an application programming interface. We'll be talking about the mechanisms that are available for using speech recognition and speech synthesis from Python and for accessing all of the open source code that's available. So this week, I'm going to tell you about the speech recognition module. And next week, I will tell you about the Google text-to-speech synthesizer, which is also available inside Python. The speech recognition module we can install by simply typing pip install speech recognition. And what it gives you is basically just a common application programmer interface that can be used to access any of these speech recognizers. It can access the Carnegie Mellon University Sphinx recognizer, the Google speech recognition engine, the Google Cloud speech API, wit.ai, Microsoft Azure speech recognizer, the Microsoft Bing voice recognizer, Houndify, IBM, Snowboy, TensorFlow, Vosk, or OpenAI Whisper, or Grog Whisper. So all of these are, as you can see, some of these are from companies like Google and Wit.ai and Microsoft and Houndify and IBM and OpenAI. Some of these are from open source projects like Carnegie Mellon University is an entirely an open source project. Whisper has been made open source, even though it was originally produced as a commercial product, Whisper has been entirely made open source. Microsoft Azure and Google Cloud are not open source. Those are commercial products, but they're made available for free. So we are allowed to use those commercial speech recognizers for free. And those are actually very high quality commercial speech recognizers. So we can use those using the speech recognition API. So here's the speech recognition module. The first thing you need to do is to install the speech recognition module, and that's done by typing pip install speech recognition. And capitalization is important. In order to get this to work inside a Jupyter notebook, you need to put an exclamation point at the beginning. So if we type exclamation point, and then pip install speech recognition, and then if we hit run on this, when I run this, it will tell me that I already have speech recognition installed. Requirement is already satisfied. When you run it, it may install it if you have not previously installed it, and or if it will either install it if you don't have it installed, or it will tell you that you already have it installed. In the rest of this lecture, I want to talk about really three things. I want to talk about how to use it, and then how to use it to recognize the speech inside a file, and then how to use it to recognize speech in real time. And in order to recognize speech in real time, we'll need to install PyAudio. So let's first talk about how to use it to recognize a file. So the general idea is that we read in some audio file as a source. So we first import the speech recognition module, and then from the speech recognition module, we create two kinds of objects. First of all, we create a recognizer object. This is the actual speech recognizer. Second, we create an audio file object, and this is the audio file from which we're reading. And then the recognizer will record from the source. This takes the audio in from the audio file into the speech recognizer. And then the recognizer we can type r.recognize Google, for example, in order to run the Google speech recognizer to convert that audio into text. So we read the audio in from the source file, and then we convert it to text. Those are the two main steps. This particular audio file I've distributed with the source. So it's this FLAC file here, which if I just open it, I think I will be able to play it. No, I'm not able to play it. Let me then open it in the Finder. Here we go. Let's go to, where are my documents? Here we go. So if I open this audio file, you'll be able to hear what it says. Let me view and edit it in Prot. Here's the audio file. And if we play it in Prot, we can hear it, listen to it like this.
Thank you. Please wait for assistance. Grazie. La preghiamo di attendere per ricevere assistenza.
This is an audio file that I downloaded from SoundCloud, I think. In order to find the actual website for SoundCloud, it looks like I need to go through several. Let me see if I can just go to soundcloud.org. No, how about soundcloud.com? Here we go. So from SoundCloud has a wide variety of audio, and it also has some public domain audio. The particular audio file that I've played for you is a public domain audio file from SoundCloud, and you can hear that it starts out. It's basically a translation of a telephone answering machine message in both English and Italian. So this first section is the English file.
Thank you. Please wait for assistance.
And the second part of the same audio file is the Italian part, translation of the same statement.
Grazie. La preghiamo di attendere per ricevere assistenza.
Right? So now what we want to do is we want to try to recognize that using the automatic speech recognizer. We're going to import the speech recognition module, and then we will read in that audio file as a source for audio. We'll record from that source into memory. What this line does is it reads the audio file into the computer memory so that it can be processed in computer memory. And then we will convert it into text, and it will say what the person in the audio file said. When I run the speech recognizer, it says, the person in this audio file said, "Thank you, please wait for assistance," which is almost true, but not quite. Well, I'm sorry, this is from Freesound, not from SoundCloud, my mistake. This audio file is from freesound.org. And so if I play it on freesound.org,
Thank you. Please wait for assistance. Grazie. La preghiamo di attendere per ricevere assistenza.
so we can hear that what the Google speech recognizer thought it heard was just the English part of that utterance. Thank you, please wait for assistance. And like many speech recognizers, when it detected Italian, it didn't know how to transcribe it because it's been programmed to expect only English. It hasn't been programmed to expect any other language. If you want it to understand speech in some other language, we need to specify the other language. Let me see. Let's try just specifying language equals Italian and see if that solves it. I don't remember if that's the right syntax or not. Okay, let's go back to the speech recognition toolkit and find out. Python M speech recognition. I'm sorry, I don't remember what the correct tag is. Um, let's search for Python speech recognition um, language and see if we can find a help file that will specify how that's correctly done. Pass in the language argument. I just did that, didn't I? What did it not get? Got an unexpected. Oh, it's not here. It's into the recognize Google. That's why. So let's go down to recognize Google and let's tell it to try to recognize in Italian and see what it does. Okay, now when I tell it to try to recognize in Italian, then it gets the Italian quite well. Grazie, lo preghiamo di attendere per ricevere assistenza, right? And it also actually recognized the English. This is kind of a common thing in speech tools that regardless of what language you tell it to expect, it will often also listen for English. But it didn't do quite as well with the English when I told it to recognize in Italian. Right? Rather than saying, thank you, please wait for assistance, it thought that I was saying, thank you, please wait for sisters. And so depending on what language you tell it to use, it will do better or worse it will usually do, the Google Speech Recognizer does very well in the language that you tell it to use, and it sometimes gets part of the other language and sometimes not. All right, what we really want to do actually is tell it to recognize the first half of the audio file in English and the second half in Italian. And the way we can do that is by going to something like Prot and finding out where the break is. Looks like the break is at around 4 seconds. And so if we recognize the first 4 seconds in English and the last 4.5 seconds in Italian, then we should get good speech recognition results. So we can read in the audio file using Librosa. We'll go ahead and read in the audio file y, sr equals librosa.load, and then we will print out the entire length of the file. And then I'll create a time axis, which is the length of the file in samples divided by the sample rate. So it will show in the x-axis, it will show the time in seconds. And then I'll use matplotlib to plot that file against its time axis in seconds. And then the result, I get something that looks like the Prot display. As you can see, it will show that the first 4 seconds or so of the audio file are in English and the last 4 seconds or so are in Italian. Goodness, it seems like it takes a long time to load. The length is 188,928 samples. The sampling rate is 22,000 samples per second. The duration is 8.568 seconds. And you can see that the first 4 seconds are the part that must be English. Thank you, please wait for assistance. The last 4.5 seconds are the part that must be Italian. Grazie, lo preghiamo di attendere per ricevere assistenza. I forget how that's spelled. All right, and we can listen to it using the IPython display audio.
Thank you. Please wait for assistance. Grazie. La preghiamo di attendere per ricevere assistenza.
Per ricevere assistenza. So as you can see, the file has two parts. The first 4 seconds are in Italian or in English. The last 4.5 seconds are in Italian. What we would really like to do is to tell the speech recognizer to only read in the first 4 seconds and to recognize that in English, and then to read in the rest of it and understand it in Italian. And one way to do that is to simply specify the duration tag when we do the r.record. You remember r.record reads from the audio file into an object in memory, and then we take that same object and we recognize it using the Google Speech Recognizer. So in this case, if the first audio is just the first 4 seconds, I specified duration equals 4. And then I can recognize that using English. Then when I call r.record on the same source again, well, notice that this is all inside of a single with statement. And so within this single with statement, this source, the file stays open. I'm not closing the file and reopening it. I'm keeping the file open during all of this time the file stays open. And so since it stays open, after it reads in the first 4 seconds, if I call record again, it will read in all of the rest, whatever's left after the first 4 seconds. And so I can run this segment and it will read in the first 4 seconds and say the English part of this audio file says, thank you, please wait for assistance. The Italian part of this audio file says, grazie, lo preghiamo di attendere per ricevere assistenza. Right? And so we can get the best possible recognition accuracy by telling it which language to use to recognize each part of the audio file. All right, now we know how to use the speech recognition toolkit in order to read in the audio file. And we know from there how to record into memory and how to translate it to text using Recognize Google. Now let's see how to do that in real time. Suppose you want to talk to your computer and you want it to understand what you say. In order to do that, you need access to the sound card on your computer. In order to get access directly to the sound on your computer, you need to install PiAudio. And when I wrote this notebook, this was the correct way to install PiAudio. Conda install PiAudio-Y. And as you can see, that now fails. So if I run this, it will tell me that that program fails. It's not able to install PiAudio in that way. So let's just wait for it to fail and we'll see that it fails. There's a warning, added empty dependency. And now it says that it failed. So this particular method that worked when I created this notebook no longer works. If we try importing speech recognition and doing the speech recognition from a microphone, it will, well, it says that it worked, but it will fail in general. The correct way to install PiAudio now is to type pip install PiAudio. That simply. Let me just check to make sure on that. Pip install PiAudio. There we go. Pip install PiAudio. All right, so let's go ahead and just type pip install PiAudio, and that should work. In fact, for me, it will tell me that I already have it installed. All right, so if you just type exclamation point and then pip install PiAudio, that will install it correctly, and then you'll be able to use the microphone to recognize your own speech. What PiAudio does is it gives Python access to the microphone on your device. So on your laptop computer, there is a microphone, and Python needs access. And so if we use speech recognition.microphone, then that will give it access to the microphone. And so we can just run this little code snippet, and if there are no mistakes, then that means that Python was able to get access to your computer's microphone. Sometimes, depending on how Python is installed on your computer and depending on the operating system that you have running on your computer, this may not work. If this doesn't work, you will still be able to do the homework, but you won't be able to do section 4. And so if this fails, don't worry about it too much. You can watch what I'm doing and it will not affect your homework. But if you can find a way to get it to work, then you might have more fun, right? If you can get the microphone to work, then you'll be able to try the real-time speech recognition that I'm going to show you in the next part of the lecture. All right, real-time speech recognition has a lot of different issues that can happen. And the way that we address those issues is by using try and except. This is the standard way to do error handling in Python. Let me open up information about try and except. So exceptions are these kinds of mistakes. For example, if we try to do 10 times 1 over 0, then 1 over 0 is a division by zero error. So all of these mistakes, what happens is when you run this line of code, Python says, that's an error, and it throws what's called an exception. And an exception normally stops processing, right? It normally will stop the computer and say, this is a mistake, I can't do this. In this case, the particular kind of exception is a 0 division error. If I say 4 plus spam times 3, I get a name error, meaning that the name spam is not defined. If I take the string 2 plus the number 2, then I get a type error. I can't concatenate a string with an integer, right? All of these kinds of errors can actually be caught. If this line might generate an error, then you can put that inside of a try clause and follow it up with an except clause. And what the except clause does is it watches for any mistakes that happen during the try clause. And if a mistake of the kind value error, if an exception of the kind value error occurs, then instead of stopping the program, it will run this line instead. And so that's how we're going to treat errors in speech recognition. We'll say with the microphone as the source, we're going to try to read in audio from the microphone. And the first thing we'll do is adjust for ambient noise. What this does is it adjusts for your background noise. So if you have fans running in the background or traffic in the background, then this line will listen to your microphone for just a little while in order to understand what kind of noise is occurring in the background behind your speech. And after it listens to your background noise for a little while, then it will try to subtract that noise from your speech when you begin speaking. Next, we're going to try listening to the microphone. So r.listen means try to read in audio from the microphone. And r.listen automatically includes modification of the background noise. And then we'll try to recognize the audio that we hear. All of this is inside of a try clause, which means that if either of these two lines, if r.listen or r.recognize Google has any kind of error, the following 3 kinds of errors have special processing. I say if we get an unknown value error from the speech recognizer, what that means is that this recognize Google, it tried to recognize the audio and it couldn't recognize anything in the audio. Right? Maybe there's some noise that it heard, or maybe there's some noise, or maybe there's some other problem. And so what we're going to do is print, I did not understand that, I will try again. If we, the other 2 kinds of errors that we can get have to do with internet access. So if we, well, no, this one has to do with internet access and this one has to do with silence. So this one has to do with internet access. The recognize Google, this version actually takes your audio and sends your audio to the internet and gets a transcript from the Google Speech Recognizer on the internet. So if we go back to the speech recognition module, where is the speech recognition module information? Here we go. If we go back to the speech recognition module, you see that some of them are labeled as works offline, CMU Sphinx and Snowboy hot word detection and Vosk API and OpenAI Whisper. These work offline by actually downloading the entire speech recognizer to your own computer. Things like the Google Cloud Speech API and the Google Speech Recognition only work if you're connected to the internet. And so you have to be connected to the internet because it will actually send your audio to Google, and Google will process your audio and convert it to text and send the text back to your computer. If you want to avoid that, you need to use the CMU Sphinx speech recognizer or the OpenAI Whisper. And the results for the Whisper results are pretty good. The Sphinx results are not as good. The Google Cloud Speech Recognizer is one of the best, and that's the reason I'm using it. But it does have this problem that you need to be connected to the internet. A request error occurs if you tried to send the audio to the internet and get text back again, and that failed. And so in that case, we're going to print, sorry, I could not reach the internet. I will try again. The third kind of error that we'll address is what happens if it listens for a whole second and a half or so, and it hears nothing. If you don't say anything, if the background, if your microphone is perfectly silent during that time, then that's called a wait timeout error. It waits for you to say something, and it waits for a certain number of seconds, maybe 5 or 10 seconds, and you don't say anything, and so it generates an error. That happens from this audio equals r.listen source. It's listening and listening and listening, and you don't say anything, and so it generates an error. We could do something special with that error. We could say, we could tell it, oh, you didn't say anything, and so I'm going to go ahead and do some other task. But instead, what I'm going to do is just type continue, which means that if it times out, I want to go ahead and try again. Right? So it's going to use this, it's going to do this while true. Right? This while true means that if I reach a continue, that it goes back and tries again. This continue, print, sorry, I could not reach the internet, I will try again. The continue means that it goes back to this while true and tries again, right? Here, the continue means go back to while true and try again. And the only time when we don't continue is if none of those are true, then we reach a break statement. And the break statement breaks out of the true loop, right? So when we reach this break statement, we break out of the loop and we print you said and the text. So if any of these three errors occur, then we go back to the loop and we try again. If none of those errors occur, then we break and print out the resulting text. So all of this is the different kinds of errors that can occur when you're listening to a microphone. And because all of these different things can happen while listening to a microphone, we'll have special processing for all of these. Let me try running this and see how well it works. Hi, this is a test of speech recognition. And it said, hi, you said, hi, this is a test of speech recognition. Let me try it again and see if I can say something that it will not understand. Let's see if I can get it to print, I did not understand that. Blagibberty. Blook, blook. Okay, that was a good test. There we go. So at first I said blagibberty blook blook, and it said, I did not understand that, I will try again. It got some kind of text here in the recognized Google line, but the text it got was text that it did not understand, and so it tried again. Let's try, see if I can pronounce Japanese well enough for it to understand something in Japanese. これは音声認識です。Ah, it worked. これは音声認識. It didn't get my des, but it at least got これは音声認識. All right, so you can specify the language and it will listen to that language. Let's see what it does if I specify English but try speaking in Japanese. Probably it will treat it as unintelligible. これは音声認識です. All right, it translated that, it wrote the nearest sounding thing in English, play my own signage. That doesn't work very well, but now we know how to run the speech recognition toolkit. In this way, you can create your own programs that have automatic speech recognition. And if you stick to the correct language, if you tell it in advance what language you're using, then it should get pretty good results. Let's try opening the homework. So the homework will include how many different files? Let's see. The homework for this week is just one method, transcribe wave file. And the idea will be that we'll specify a language and the default will be English. You can change the default if you want. And then we'll specify an audio file name from which it should read. Excuse me. So let me run the doc string. The doc string says we want to use the SR recognizer audio file name as the source, recognize from that source, and return the recognized text. The file name should be the string, the file name from which to read the audio. The language should specify the language of the audio. Optional, the default is English. All right, so let's go ahead and remove the error here. And let's see, first of all, we need to have a recognizer. Let me go back and see what else needs to be in this method. Looks like we need to have we need to read from the audio file. So let's say, I already created R equals speech recognition dot recognizer. That should be capitalized. And then once I have the speech recognition recognizer, then I want to read in from the audio file. And so let me do that. Speech recognition dot audio file as source. And then with that audio file name as the source, I want to record from the source. And once I've recorded from the source, then I want to recognize Google in the specified language. And then once I've done that, I just want to return the text. All right, if I save that, then that should give me, I should be able to test that by reading in the same please wait for assistance file. Let's see if that works now. Let me go down to the homework here and I will run homework 11 transcribe wave file and then print the text. And it prints out, thank you, please wait for assistance, which as we've seen is what it will do if it's told that the language is English. Let's see if it correctly gets the Italian part if I tell it that the language is Italian. Yep, grazie, lo preghiamo di attendere. All right. So let's just check to make sure that this gives us the correct results from the grade.py. ... Okay, that seems to be working. In that case, we can run GitHub Desktop in order to check it in. Let's commit it and then push it to the origin. And then we'll check on GitHub to make sure that it got uploaded correctly. All right, looks like it got uploaded correctly. So now you can take the URL and copy the URL and go to homework 11. Oh, I haven't renamed it. I need to rename it. And you should be able to enter it here. Let me rename it as long as I'm here. Let me rename this assignment as homework 11 so that you can now enter the URL of your copy of homework11.py and then I'll be able to grade it. That's all that we have for today, so let me go ahead and take attendance. Okay, please go ahead and register your attendance using this code 17717. Thanks. I think we have 9 people online, so please go ahead and register your attendance. Thank you. Let me